Hey everyone, welcome back to my lesson. Today we are having lesson number 2 based on trigonometric functions. Obviously we'll be focusing on change in amplitude, shifting trigonometric functions up or down, and how to interpret the graphs, right? Grade 10 level, right? So for Okay, but before I continue, I hope everyone, we are actually having a lovely weekend and I hope we are doing good, guys. And I couldn't upload yesterday, which was Friday, because I was having a flu. I'm still having flu, but at least now I'm better. So I was like, you know what? Let me just upload something for my people so that they can be updated, right? So this is just our lesson 2 now, whereby now we focus on changing amplitude, etc., etc., right? So for grade 11s, guys, when I upload, I won't go back to how to sketch the graph, changing amplitude, the shifts and all of that, right? I'll just continue. So I would advise you guys to go back to grade 10 level, where now you can start um, learn how to sketch the graph, the shifts up or down, and then the change in amplitude. That will help you. Sharp. So on our today's lesson, we'll focus on change in amplitude. Let's start with change in amplitude. So for change in amplitude, um, in case of a change in amplitude, the graphs will be multiplied by the value of A. This causes the change in amplitude by a factor of A, right? So the graph will be in a form of y is equals to A sine x, or y is equals to cos, or A cos x, and y is equals to A tan x. Remember, for the original function, we normally have something like this. Y is equals to sine x. It's just sine x, right? Which is just sine x. So there's no value of a there. So when we introduce change in amplitude, that's when now we focus on value, whereby we multiply by the value of a, right? So example 1, on separate axis, sketch the graph of y equals to 3 sine x, y equals to 2 cos x, and y equals to 2 tan x. X is an element of 0 is to 360, the restriction, right? So obviously you have to start from the original graph, where you have your minimum and maximum as 1 and then minimum as -1, right? So obviously you will expect a graph like this for sine graph, this one here, right? But now, what happens now if the value of A now changes? What happens if the value of A now changes, right? It changes from 1 to 0. What happens? So obviously the maximum value will be affected as well as the minimum value. Here's the maximum value there. You'll have your 3, and then the minimum value, you'll have your -3 because of that 3 in front. So the first point, you will have 0 is to 0, and then for 90, you will have +3 as your y, 180, that's your 0, -3 as your y for 270, and then 360, that's a 0, and then you join a graph, joining the points, né? So that you can draw the graph, and then you will have something like this. So it's not that quite different. The only thing which is different, it's only the maximum and the minimum. So change in amplitude, that's when now we introduce a different maximum or different minimum. Same applies to 2 cos x, ne? So for 2 cos x, again, we'll do the same thing. Uh, for 2 cos x, okay, this is 2. At 2, you'll have a 0 there, and then 90, 0, 180, -2, 270 is at 0, and then 360 is at 2. And then you join the graphs, join the points, sorry, and then you'll end up having something like this, right? You'll end up having a KV shape. Perfect. And then now let's move to tan y equals to 2 tan x. So for y equal to 2 tan x, you have to first consider the sign of the tan. Sign here is positive, so the graph will first go up because it's increasing. It will go up at 180, it alternates, goes down, up again, and then 360, it will have to go down, right? And then don't forget to have your extra point there. Your extra point will be at 2. 45 is 2, 2. Now let me explain why are we having 45 and 2. So obviously the graph, we have your y equals to 2 tan x, ne? Whereby your x is 45. So you substitute 45 in place of x, and you'll end up having y equals to 2. But now you tan 45, that's just 1. And then 2 times 1 is just 2. So hence we are having 45 is to 2 there, right? What happens now if we are still having change in amplitude, but then now they change the sign of the graph? It's not a problem. It's not a problem. So we expect the graph to first decrease, right? So at 90, you will have a -3, 180, 0, 270, +3, 360, 0, and then 0 and 0 there. And then let's join the points. And then this is your graph. So it will start by decreasing because of the negative value there, the sign, right? Now the cos graph, uh, you'll have a 0, -2, and then 90, that's 0. 180, you'll have your +2 there. 270, 0. 360, -2. Now join the graphs. Now you have to join the points to draw a complete function. And then you end up having something like this. Ne? And then now let's move to the 10 graph. So again, for the 10 graph, because of the negative sign, y equals to -2. So the graph will start by decreasing. 180 goes up and then down again, and then 360 up, right? So then you'll have the extra point there of 45 and -2. I've already explained and showed you how to get -2 or +2, ne? So this is your graph. And then for the domain, you'll have x is an element of 0 is to 360. It starts from 0 to 360. And then for the range, y is an element of real numbers because the graph doesn't stop in terms of y. It continues. Those arrows are saying the graph, it continues, it doesn't stop. So hence we're having y is an element of real numbers. Or you can say y is an element of -infinity to +infinity. Make sure your brackets are open. And then now let's move to shifting the graph up or down, ne? When shifting the graph up or down, your equation will be in the form of y equals to a sine, that's sine x, right? So that's plus or minus q. Y equals to A cos x plus or minus q, and y equals to A tan x plus or minus q. So q is the vertical shift up or down, right? Now for example 1, they're saying sketch the graph of y equals to sine x plus 2. So sketching the graph of y equals to sine x plus 2. So they are simply saying the graph is being shifted 2 units up when they add 2. So your graph from will be is at origin, right? 0 is to 0. So it has to move 2 units up. 1. It's 1 and 2, right? 2 units up. 1 and 2. So I'd like to call it a new origin. Will be at now 2, not at 0, because of the shift. Ne? So negative 360, our point will be at 2. And then negative 270 is at 3. And then negative 180 at 2. Negative 90 is at 1. Let me try and erase this. And then 0 is at 2. And then 90 is at 3. 180 at 2. 270 at at positive 1. And then 360 at 2. And then you just join the point. So guys, can you see your graph now went up by 2 units plus 2. It's no longer at origin here. It was supposed to be here at 0 is to 0, but it's no longer there. It went up 2 units. So if there's plus 2 there, after your x, then obviously we're having a what? A vertical shift 2 units up, right? Now let's check another example. Y equals to x, or cos x minus 2. For cos x minus 2, again, it's not a problem. We started negative 1, then that's 0. At 90, you have your 2 there. At 180, you have your minus 3, 270, 2 again, negative 2 again, and then 360, you have your negative 1. So with that being said, this becomes our new origin. So you'll have something like this. So this is your graph of cos x minus 2, meaning the graph went down by 2 units. The graph went down by 2 units, right? Now let's try and draw the graph of y equals to tan x plus 1. Tan x plus 1. So you'll have your origin there at 1. Because your graph went up by 1, right? And then now you can start drawing a graph. Since the sign is positive, the graph will go up. At 180, goes down. And then up again. At 360, it goes down. Right? So your graph was supposed to be at the origin, but now it went up with 1 unit. Hence I'm saying plus 1 there. Right? So after that now, we need to make sure that we consider our extra point. So the extra point will be 45. So that's 45. That's 45 is to 2. That's the extra point. And then that's your complete graph, ne? Sure. And then now we are done with the vertical shift. Now we've covered changing amplitude and then the vertical shift. Now we have to go back now and try to uh, interpret the graphs now. Now we have to interpret the graphs, ne? So example one. Here's first example. The graph of f of x and g of x are sketched below. A, the amplitude, or determine the amplitude of f of x and g of x. Determine the equations of f of x and g of x, right? And then determine the domain and range of f of x and g of x, and then the period of f of x and g of x. Now let's start with the amplitude. So the amplitude is just the, okay, A is equals to y max minus y minimum, ne? Divided by 2. So what is your y maximum for the sine graph? That's positive 2 and then negative 2, the minimum. So you'll have your 2 minus 2 divided by 2, which will give us 4 over 2. And that's just equals to 2. And then for the cos graph, here's our maximum, and then the minimum is here at 0. So you'll have your 2 minus 0 over 2. That's your A, which is equals to 2 over 2. That's 1. So this is the amplitude of G, and then this is the amplitude of F, right? We're done. And then the equations of f of x and g of x. So how do we get the equation of f of x and g of x? Now, okay, let me do this. So you'll have your y is equals to a sine x plus q, right? For sine x is this one, it's this graph, ne? So for sine x, our amplitude we said is what? 2. Our amplitude is 2. So in place of a, we substitute 2 sine x. Are we having a vertical shift for sine graph? No, our graph is at origin of 0 is to 0. So this is your graph. Y is equal to 2 sine x plus 0, because it's at what? The origin. So your graph would be y equals to 2 sine x. This is the equation of f. Ne? Then the equation of g of x, you will have your y equals to a cos x plus q. We said our a is 1, so this is cos x, right? And then, but the standard graph of cos, it tends at 1, right? But then this one tends at 2. Can you see? So which means the graph went up 1 unit plus 1. So which means the vertical shift there will be plus 1. So you'll have y is equal to cos x plus 1 for that graph. So this is the equation of g of x and then the equation of f of x. Perfect. Now, yeah, that's it. Now let's move to the domain. What is the domain of the graph? Of these graphs? The graph starts here and then it stops there. So we can say x is an element. X is an element of negative 360 is to 360. Done. That's the domain. This is our C. Then the period. So to get the period, obviously the period is just 360. The standard period of cos and sine is just 360. Then we're done answering this question. That's how you interpret the graphs. But I will come with more questions, guys. Now let's move to the next question. Example 2. The graph of y equals to a tan x plus q is sketched below. Determine the values of a and q, hence determine the equations of the graph. Determine the domain and the range of the graph, and then the period of the graph. So this is a tan graph, that's the first thing. How do we get the value of a and q? Now, before we even get the value of a and q, let's start with the value of q. So for our original graph of tan, the origin is at 0 is to 0. But this graph, it went down by 1 unit. As you can see there, it went down by 1 unit. Ne? So which means now the graph has a new origin at -1, right? As you can see this part here, this one here. So which means the graph went down by -1. Perfect. So that's the first step. That's our point of departure. So A, you can say y is equals to A tan x. For q, we have -1 because it went down 1 unit. And then, remember I've emphasized the story of an extra point. Now that's when it comes in. So the extra point, you have your 45 as your x, -1, which gives us the y value of 2, right? Now, tan 45 is just 1. So you'll have your 1 times a minus 1 equals to 2. Then let's transpose. And then you'll end up having your 3 because now you're transposing -1 to the left-hand side. Now your a is equals to 3. Now give us the equation because they said hence. Give us the equation. So meaning now, when they say hence, now they're saying whatever that you are having, use it to get the follow-up question. So you have your y equals to a, that's 3 tan x minus 1. So this is the graph. This is the equation of the graph. I hope it makes sense. I hope it makes sense. Then, now, B, the domain and the range of the graph. Now we're looking for, let's start with the domain. Domain for B, x is an element of 0 is to 360. That's the domain. And then the range, because of these arrows, which implies that the graph doesn't stop in terms of y, which means you will have y an element of real numbers. The graph doesn't stop in terms of y values. It continues. Or you can say y is an element of negative infinity is to infinity. Perfect. And then we're done. And then the period. The period of the graph is just 180 degrees. That's the standard period of a chart graph. So in every 180, you get a complete cycle. So here's the complete cycle here at 180. Now, the story of period. The period is just a horizontal line to complete one cycle. Now, how do you get a horizontal length when it comes to graphs? We say right value minus the left value, right? So 270 minus 90, you get what? 180. So in every 180, you get a complete cycle. That's why we are saying the period of third graph is 108. Ne? Sharp. So I hope guys you've understood everything and I hope you've enjoyed my video. So now we've come to the end of our lesson number 2. I'll see you guys in our next video. Bye.